Hello everyone, welcome to Neso Academy. In the previous lectures, we have understood the concept of classes and objects, and we have also understood how to define member functions of a class. Now we are in this lecture, and the name of this lecture is Static Data Members. In this lecture, we will properly understand what are static data members and how we can define them. So without any further delay, let's get started with this lecture and let's see what are the topics. The first topic is Introduction to Static Data Members. First, I will introduce you to static data members. Then, through an example, we will understand how to declare, use, and define a static data member. So these are the topics. Let's start with the first one, that is Introduction to Static Data Members. So what are static data members? A static data member is a member of the class that can be declared using the keyword static inside the class. So within the class, we can only declare a static data member, and we can declare the static data member with the help of the static keyword. If we want to define the static data member, then we can only define it outside the class. This is what I have written as the second point. It must be defined outside the class. Also, it is shared by all the objects of the class. It is not the case that each object will receive its own copy of the static data member. Every object has to share the same copy of the static data member. So it is shared by all the objects of the class. Also, if we want to access a static data member, then it is possible through the class name, not the object name. So it can be accessed using the class name because it is created on a class basis, not on an object basis. It is not associated with an object. It is associated with the class. I hope these points are clear to you. Now, let's see how to declare a static data member inside the class. Let's see the syntax for the same. This is the syntax we can follow to declare a static data member inside the class. We need to specify the keyword static, then we need to provide the data type of the data member, and then after this, we need to provide the variable name or the data member name. So in this way, we can declare a static data member. Now, what about its definition? How we can define a static data member outside the class? This is the syntax we can follow. First, we need to specify the data type. Then after this, the name of the class to which it belongs. After this, with the help of scope resolution operator, we can define our static data member. We need to provide the name of the static data member after the scope resolution operator. So this is how we can define a static data member. We can also initialize the static data member at this moment. We can use the list initialization or copy initialization or other forms of initialization. I hope this is clear to you. Now let's see how to use a static data member. This is the usage of static data member. We need to specify the name of the class, then after this the scope resolution operator, and then the name of the static data member. Now here you can observe that we are using the scope resolution operator to define a static data member and to use the data member outside the class. This is the use case of the scope resolution operator. We already know that with the help of the scope resolution operator, we can access global variables inside the function. Also, with the help of scope resolution operator, we can define member functions outside the class. In the same way, we can define static data members outside the class with the help of scope resolution operator, and this operator is also useful in accessing the static data member outside the class. I hope this is clear to you. Also, I would like to mention that by default, static data members are initialized to 0. So all static members are initialized to 0. If we do not provide any initialization value to the static data member, then it will be initialized to 0 by default. So these are the points about static data members. And now we know how to declare, define, and use a static data member. We at this moment only know the syntax. Now let's implement this. For this purpose, we need to move to the next topic, and through the example, we will learn how to declare, define, and use a static data member. For now, we are done with the introduction to static data members. Let's move to the second topic to understand through an example how to declare, define, and use static data members. Here is the example program. I have included IOStream header file, and here is the definition of the class student. Within this class, I have declared this public keyword. This means the code following it is meant to be public. This means it is accessible to all the functions outside the class. Now here is the normal count variable, and it is initialized to 0. This is the normal data member, and therefore whenever we create an object of this class, then the object will receive its own copy of this data member. This is what we need to remember. And this is what we have already learned as well. After this, I have defined this static data member as well. After this, I have declared this static data member as well. I have followed the same syntax. First, I have specified the data type as static int, and then the name of the variable, which is static count. This is just the declaration, not the definition. Also, we must remember this, that this variable will be shared by all the objects of this class. Here is the definition of the static count variable. Here you can observe the same syntax being followed. First, the data type is specified, then the name of the class, then after this, the scope resolution operator, and then the name of the static data member, which is static count. And it is initialized to 0. Even though we do not initialize it to 0, it will be automatically initialized to 0. So now we know this static count variable has been defined and it is initialized to 0. After this, we have this constructor called student. I'm calling this the constructor, and we already know what a constructor is. I gave you the brief idea about what a constructor is. A constructor is a special type of function which gets called whenever the object of the class is created. So it will be called automatically when an object of this specific class will be created. Here we have this code, and with the help of this code, I am incrementing both normal count and static count by 1. Now here is the definition of the main function. In this definition, we have these 3 objects S1, S2 and S3, and these objects are of type student. So these are the objects of class student. As the object S1 is created, the constructor is called and normal count is incremented by 1. We know that S1 has its own copy of this variable normal count. It will be incremented by 1. Therefore, S1.normalCount is equal to 1 because it has been initialized to 0. Now it is equal to 1. I hope this is clear to you. Now what about S2? Because S2 is also created, constructor is called again, and normal count is incremented by 1. But S2 has its own copy of this normal count variable. It will be incremented by 1. So S2.normalCount is equal to 1. It has to do nothing with S1.normalCount. S2 has its own copy of the normal count variable. and it has updated normal count to 1 because of this constructor. Now, what happens in case of S3? Because this object is created, constructor is called, normal count is incremented, S3.normalCount is also equal to 1. So we know at this moment S1.normalCount is equal to 1, S2.normalCount is equal to 1, and S3.normalCount is also equal to 1. Now, what happens in case of static count variable? What about this specific variable? We know S1 object is created, therefore the constructor is called, and static count variable is incremented by 1. We also know this that static count variable does not belong to an object. The same copy of the static count variable will be shared by all the objects. Because of S1, static count will receive value 1. This happens because of this line. I hope this is clear to you. So now static count variable has value 1. What about S2? Because of S2, constructor is called, static count is incremented by 1. Now it has value 2. Please note that S2 does not have its own copy of static count variable. The same copy of static count variable is incremented, and therefore we are getting value 2 inside this variable. I hope this is clear to you. The same thing happens for S3 as well. Again, static count is incremented by 1 and we will get value 3 in this variable. So we now know that static count is equal to 3. And with the help of these std_cout statements, I am trying to display the results of s1.normalCount, s2.normalCount, s3.normalCount, and student static count. Here you can observe that I am using the syntax of accessing the static data member within this main function. First, I am specifying the name of the class, then the scope resolution operator, and then the name of the static data member. In this way, we can access this static count variable. Now, when we execute this program, we will get the output s1.normalCount equal 1, s2.normalCount equal to 1, s3.normalCount equal to 1, and shared static count equal to 3. Here we can observe what we have expected. So from this example, it is clear what is the difference between normal data member and static data member. Each object gets its own copy of the normal data member, but each object has to share the same copy of the static data member. That is why we are seeing this output. So with this, we are done with this example, and this means we are done with the last topic as well, and therefore we are done with this lecture. Okay friends, this is it for now. Thank you for watching this lecture. I will see you in the next one.